Business Calculus, Topic 5, Homework Problem number 28 and 29. We want to take the antiderivative of this problem. First, I want to convert this root right here to a fractional exponent. So this will be x over x plus 6 all to the 1/2 power dx. Then I want to turn this into a product, which will be x times x plus 6 all to the negative 1/2 power dx. And now to take an integral of this, I want to use substitution. So all of this will be considered u. So I'm going to let u be represented by x plus 6. Then the derivative of u will be the derivative of x, which is 1, derivative of x is 6 is 0, times dx. And this gives me a replacement for my du. But notice I have no replacement for my x. Well, since u equals x plus 6, then that will imply that u minus 6 would represent x. So this x right here could be rewritten as x minus 6. Alright, so with all my replacements, the x becomes u minus 6, and the x plus 6 becomes the u to the negative 1/2 power, and the dx becomes du. Now I'm going to distribute my u to the negative 1/2 power. Remember, this is u to the 1 power, so when we add exponents, this will be u to the positive 1/2 minus 6 u to the negative 1/2 du. Alright, now to take the antiderivative, we're going to add 1 to the power here. We're going to get u to the 3/2. And the reciprocal of 3/2 will be 2/3. Okay, here we're going to add 1 to the exponent. It becomes 1/2, and the reciprocal of 1/2 is 2, and then plus c. Now I'm going to return all the u's back to x plus 6's. So we'll have 2/3 x plus 6 all to the 3/2 power minus 12 x plus 6 all to the 1/2 power plus c. Now this solution here will go well back into the computer as an answer, because the computer kind of likes the fractional exponents. If you were testing on paper, you would actually convert the fractional exponents to roots. So this will be the square root of x plus 6 all to the 3rd power minus 12 times the square root of x plus 6 all to the 1st plus c. Now, number 29. We want to calculate the Riemann sum for the given function over the given interval using the given value of n. Okay, so the function is 80x minus 20 over the interval 0 to 2, and we're going to use 4 rectangles. Well, let's first begin by finding delta x. The formula for delta x is b minus a divided by n. This is our a, and this is our b. So this will be 2 minus 0 all over 4, which comes out to be 0.5. Next, we need to find our x's. The formula for our x's will be x of I equals a plus I times delta x. So our initial x of 0, will be a is 0 plus 0 times 0.5, and all that equals 0. My x1 will be 0 plus 1 times 0.5, which is 0.5. My x of 2 will be 0 plus 2 times 0.5, which will be 1. And my x of 3 will be 0 plus 3 times 0.5, which is 1.5. Okay, so this is our first step, is to get our deltas. Step 2 is I get our x's. Okay. Now our third step is to get our heights of each rectangle. So we'll say f of 0, f of 0.5, f of 1, and f of 1.5. Okay, now f of 0 will be 80 times 0 minus 20, which will be negative 20. 0.5 is half of 80, which is 40 minus 20, which is 20. 1 will be 80 minus 20, which is 60. And 1.5 times 80 will be 120 minus 20, which is 100. The fourth step is to estimate the Riemann sum from 0 to 2 of the function 80x minus 20. So the sum of these right here times dx. We can approximate that because the sum of these will be 160. The delta x is going to be 0.5. And when we multiply all those together, we get approximately 80 for the area.